So, well, moment, let's change the screens, that's it. Welcome, thank you very much for coming. And we're going to do an interesting speech about developing an IoT system fully based on FIWARE and from the scratch. We have nothing now. First of all, I present myself. I'm José Benítez. I'm CEO from FIWARE. Welcome, everyone. Hi. Let's go back again. Wow. Welcome, and we are going to present the developing an IoT system, FIWARE-based from the scratch. And I'm presenting myself now. I'm José Benítez. I'm CEO from FIWARE, a company that is fully developing FIWARE systems nowadays. And yeah, I'm also project manager, FIWARE developer, IT lover. I'm also the lady who cleans all the desks and everything in the company. So my background is telecommunication engineer, and we begin with FIWARE in, February from 2015. Okay, let's be a little bit quick. The objective from today is to connect two different devices from prototyping, which is an Intel Edison, which I have here now on my desk, and a Raspberry Pi, which I didn't bring, so I will use my own computer. The important thing is not the devices, but the different protocols that they are going to use, which is ultra lightweight, is the most common IoT protocol in FIWARE. And then another one very interesting that I love, which is lightweight machine-to-machine. And the difference between them technically is that one uses TCP and the other one uses UDP. What in means of data sending and so on, lightweight is much lighter than ultralight. But, well, ultralight, of course, has its, other possibilities. So this was the objective of today, and these are the tools we are going to need. The first one is a cloud. We could use any cloud, but since this is developing a FIWARE system, we will going to use FIWARE Lab, and we will cover a little bit how you launch an instance, configure the security groups, and so on. Then we will use, of course, the generic enablers. We could use more, but we were going to use an Orion context broker and two IoT agents for each one of the protocols, ultralight and lightweight machine-to-machine. Finally, we're going to represent the data in a dashboard. We could use another generic enabler here, which is WireCloud, but I'm more comfortable with Freeboard. I don't know if any one of you knows about this, but it's really, really cool, very pretty, and it's prepared to FIWARE. We will see it later. So this is the simple architecture in order you to don't get lost, because the presentation will be a little bit techy, but keep this in mind. We're going to do exactly this, okay? A little bit of theory, in case you're not very technical. The generic enablers are like Legos, are libraries which allow you to implement, parts of codes to make your life easier. And then this is Orion Context Broker. You know about this, I hope. The two different IoT agents, FIWARE Lab, of course, the cloud of FIWARE, and the devices with their protocols. So, well, Freeboard, of course, for the data visualization, as I said. So these are the steps we're going to follow. First of all, we're going to launch a FIWARE Lab instance with all the security groups, with the IP configuration and so on. Then we will go in to access the machine via SSH, and well, we're not going to install Docker, but we are going to configure a Docker compose file, which is now step number 3, and then configure the containers. I have them pre-configured, so we will go very, very fast from that step. Moving to the configuration of the devices, which I will go pretty fast because we have few time. And finally, the interesting part is connecting the devices to the cloud and see the real-time changes. Finally, we are going to see all the data being updated in the dashboard. So please, I mean that if you get lost, you can stop me. You can ask whatever thing you need, okay? So let's go. Well, you have there my contact info, but we can check it out later. Okay. Okay, so first things first, we are going to go to FIWARE Lab, okay? I have previously logged myself in because it takes a little bit time, but well, when you log in, you find this dashboard. Usually this is empty, but I have prepared my own machine. But let's launch a new instance, okay? We can pick here, or we can do directly from images. And let's use a basic instance. For example, an Ubuntu 14.04. We put a name, blah, blah, blah. And we select a flavor. This was a topic before in FIWARE Lab, so I will go a little bit fast. We select a key pair in order to be able to connect via SSH. This is important. If you don't have any key pair imported previously, you can create a new one. And we select our security group that we will configure it later. Finally, the network, we will select this one, for example. If you have any doubts, you can select everyone. But, well, let's skip this. Don't touch this. This is not very recommended to touch. And you have the summary with some advices. We launch the instance, but, well, we don't care about this machine right now. But if you remember, we have selected a security group, which is default. If we have selected another, we will edit this. And the important thing to access the machine and to mount the system is to open the ports, okay? I have here plenty of ports open because of another test, but the important thing is this, okay? Port 22 open, because otherwise we will not be able to access via SSH. So we have now the step 1 completely completed, okay? We have created our machine. We have selected the security group. Well, we didn't allocate the IP. We have to put a public IP. So here you will select your public IP to be requested. And, well, I only have one IP, and I have 0 available because I have it here. We select the IP, and finally we associate the IP with our machine. Okay, now it's already associated, as you can see here. So what we want to do now is to log via SSH to this IP. Until now everything is clear? Okay, I hope so. In order to connect to the machine, we're going to log via SSH, okay? The command is really common. And we use our key pair, and we connect with the user, Ubuntu, because we created an Ubuntu image, and to the IP, which I know is from memory. Okay, we are now into the machine. What we will need to do now is configure all the dependencies, which I have already installed, but you can check the manuals in the internet to install Docker, for example, and Docker Compose. This is what we are going to use, and I will stop a little bit here. We have to create a file, and if we remember the architecture, okay, we will need to use different agents, 2 agents and an Orion context broker. All of them require a MongoDB, and we are going to configure that into Docker. Can you see the terminal okay? More or less, kind of. Let's do a little bit zoom. Now, it's okay? Yep, perfect. So what we have in this gem YAML file is the description of the different enablers. Docker Compose uses this syntax, which is pretty clean, but you can check in the manuals how to configure these different lines. What we're going to do now is to put a name into every Docker container, and we are selecting from the Docker Hub what image corresponds to this name. This is the meaning of this sentence. Then we were going to link our images to another containers. For example, Orion needs a MongoDB, which is declared here, okay? And so on. With this file, we are declaring our our own architecture. And well, I have some cheats here. I have prepared my own configuration of the containers and put them into the Docker Hub. And well, I am using these images, which are mine, but they are public. Finally, you know, the ports that we are going to use to the internet. And the other things are just silly options for the system to go smoothly. So what we have to do now is to use Docker Compose app. With this, the system will do the pool of different containers. And when this has finished, you can see, you can see that the Docker containers are there, okay? We have these different images, well, but they don't, we have the IDAS, the IoT agent number 1, the IoT agent number 2, the Orion, and the Mongo, okay, with their ports open. Let's check it out, okay? We have completed the second and the third 3.1 steps. Let's configure the containers. The containers, for the people that doesn't know what they are like virtual machines inside my instance, okay? So we can access them and configure it. So everything this can be done with Docker. If we use this command and we put for example, the lightweight machine-to-machine container accessing via bash, we will have a new prompt there, and we will be in a new directory. In this directory, we have several files, but this is already running. The only thing we have to touch here is the configuration. There are several configuration files, but if you pull from the Docker repository, the important one is here, config blank, okay? So we can take a look about what is inside and the policies that the IoT agent is following. And I will tell you what is the important thing here. This is okay, not very critical. You are telling here where is the Orion context broker, the port that is using Orion, and now the port where Orion expects to receive all the data from the devices using lightweight machine-to-machine. Finally, here we have to be a little bit careful. I have put this IP because corresponds to this one, because usually it puts here localhost, and when you are inside a virtual machine and put localhost, doesn't correspond. Okay, very technical issue, but you know, it gives a little bit of headache. Whoop. One moment. Well, this has crashed. Maybe for the internet connection. So configuring the different containers is as simple as this: logging into the different containers and touching the configuration file. I have already configured everything to go smoothly because we don't have a lot of time. And we will move to configure the devices. Okay, I have here an Intel Edison. I think many of you know about this board, but it's, you know, like Arduino or Raspberry. Actually, it has a shield for Arduino. But what we are going to do now is configure this board. I have connected in my laptop. And if we put following command, screen, and we go to the location where it's connected, let me check, USB, serial, this one, we put the baud rate and this option, and it will have this prompt. We will need to log in, and then we will need to configure the board, okay? Configure Edison setup. The password that you want to put into the system again. And well, we can leave this empty. And now the Edison is looking for a Wi-Fi, okay, to be connected. It will scan for 10 seconds, and we will select the same, this is important, the same Wi-Fi that it's in your computer in order to be accessible from it. So let's use number 8, which is FIWARE. It is correct. And let's put the password. Okay, the connection has been initiated, and finally it will go everything okay, I hope. Yeah, okay. We have this IP now, or this other one, this domain. And what we need to use now is another tool, which is an IDE, programming environment. And we will need to connect to the board. We could connect directly from the board and do everything from the terminal, but we have this pretty good tool from Intel, and we can add a manual connection here and put the IP that we have just seen with our password. And it will try to connect, and okay, connection established. Finally here, you're going to program the board, and I have developed a little bit program with a screen with the I2C port and a temperature sensor, okay? But the thing is, apart from configuring these sensors, is to implement the ultra lightweight protocol. If we read about the specification, you only have to send to our IoT agent and its port a body, a content saying the attribute that do you want to modify, separated from a pipe the value that you are going to send. So this is implemented. We could use this program. If you want it, you can send me an email or whatever, and we can discuss it. If you have any doubts, of course, I will tell you anything. So if we run the program, which is running already, we will let that part, and we will see what is happening then in the last part of the data visualization. Let's move to the second device, okay? This is clear, the Edison. Any big doubt or anything? No? Let's move, okay. I wanted to bring the Raspberry, but the Raspberry actually is like a computer, okay? Since you are logged in your Raspberry, it acts exactly the same as a Unix system. So in order to implement the lightweight machine-to-machine protocol, we will use a project called Wakama, ¿vale? Okay? And this is the project. Let me show it for you. It's based in C, and there is another one called Leshan that is an implementation of lightweight machine-to-machine in Java. And if you follow the steps, you clone the repository and so on, and you install it. We have just cloned the repository, and we find this. We follow the manual. You have to do these commands, cmake, make, and then finally you will have your server. Before doing this, we are going to go to the examples folder, to a client, what we want to implement, and we only have to touch for this presentation. Then you can do your system as complex as you want, but we only have to tell this client where it must send the observations. In order to do that, we are going to modify the client in C. Okay, and the only thing that I was telling you have to modify is the IP. It's as simple as that. This is our machine in FIWARE Lab. Once you have done this, you only have to make, and well, this has been completed, and we execute the program. Okay. For executing the program, we have to specify the option -4 using IP version 4, and specifying the port that we are going to use. We had configured this port before in our Docker configuration, okay? So if we do this, we will have, sorry, I forgot to zoom it. We have a registering notification, and we have received from our server the confirmation. We have now the two devices connected. Let's move forward to the next step. Well, see the real-time changes, which is part of number 6, data visualization with Freeboard. If we go to Freeboard, I have logged in myself, and I have this, and I will explain how to connect our machine, the devices, to this dashboard. We have this panel here, which are data sources, and we need the data sources from FIWARE, okay? When you connect a device with an IoT agent, it automatically, you can see that I haven't touched for nothing Orion. This automatically uploads the context information to Orion Context Broker, okay? So we have here the different data sources, and this is the good part. We have FIWARE Orion. If we configure this and put here the different, well, you know, the name of the data source, the host and the port, which will be this, and the headers, which are, if I don't remember badly, these two. This has been configured into the enabler. These two, the type is a thing, and the ID is lightweight machine, to machine, something like this. Well, I have it configured above, and that's all. This is all you need to configure in order to dashboard, retrieve the data from Orion Context Broker. But, okay, so if we save this, we will have here this data source, but it's the same than this one. Probably I messed up in any of the parts, but I have it prepared. So what can we do now with the data source? We can add a new pane here, and we add widgets. Dashboard is everything about widgets, okay? So let's add, since this is an Edison and we have a temperature sensor, let's do a gauge, for example, with a title, live demo, for example. And here we will select our data source, which is, let's choose Edison because the other one wasn't running correctly. Data source Edison has a field named context responses, an array which is 0, context element. Let's choose the attribute because the value of the temperature is what we need. And okay, let's save this, not a number, something has going not so good. And I think it's a matter of this. Let's choose this again, and let's choose another element. Attributes, I took before number 1 or number, oh, I don't remember. Well, let's, this, I think this is the correct one. Okay, and now a number is appearing here. You have seen a change from 22 to 23, but if we do a little bit of heat into the sensor, we will see the changes eventually. There it is, a few degrees. So this was the last part from the Edison, and let's check it out with the lightweight machine-to-machine, okay? The implementation of lightweight machine-to-machine is with a client right now. This is virtual from my computer. And we have defined in the configuration of the enablers different resources which we can update to Orion Context Broker, okay? So with this client, if we, well, we can see the help. And if we use, for example, change the value of our resource, oh, sorry, something has, no. I forgot to tell. and sometimes in the IoT devices, you have to do what is called a pre-provision. This is telling to the agent which attributes is going to have the device. We can do this with a REST request, okay, which is pretty ugly, but it works now. And if we send the pre-provision, we are telling to the IoT agent what he is expecting to receive from the device. Otherwise, we will have generic attributes. So we have pre-provisioned now the the lightweight machine-to-machine, and we are now going to change the value of our resource, okay? Well, which is mapped this way because we have invented it, okay? We can change these numbers as we want. Let me check. Well, let's try with number 3. With the resource number 3, we are going to put a value of, for example, 132. Okay, the value has been changed, and now I will update in Orion Context Broker this value. This is a middle phase that usually in a platform is done automatically, but well, this is a little bit simulated. And well, if we execute that, we will store this value in our dashboard. There it is. Okay, it has been configured the same way that the Edison was in the data sources. We had a pane and we selected the attributes. We can see the, let me close some windows so we can see this. One moment, please. We don't need this anymore. Let's do it a little bit. Yeah. Let's see the real-time change of the protocol. We have changed the value and we will send the notification. And well, there is a change. Everybody seen that? So, well, this is only the beginning from an IoT system fully developed with FIWARE, okay? The last thing I wanted to say is that, for example, the bytes sent and received are all very, 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 very few. This is a very, very interesting thing because the M2M cards are really expensive in the data usage. So we want to optimize this in order to avoid more costs, okay? So this is all. I hope you don't get so lost. I did myself. I did all that was in my hand. But if you have any doubts, questions, this is the moment. And there are other moments in the corridor and via email, of course, okay? So please, do you have any doubt? I hope yes. Do you have any? I am that good. I have explained everything well. I can imagine that. Yeah, is everything clear? So thank you very much for coming and for your attention, okay? Thank you very much.